Hi, everybody. Welcome to Chemistry 140 here at Everett Community College. Before we get started, I had to push a button because I didn't actually capture the right window for the chat. Is this what I want? Yeah, that's right. Okay. I can't see where it's resizing to. There we go. Okay, that looks good. That looks good. That's not even the right syllabus that's there, so we'll just go boop. And this should pop up when I do that. Okay, cool. Sorry, I meant to do that before, but I just got out of a lecture and left everything here and was like, oh, I'm sure it's fine. Like, wait, no, it's not. Let's get started without further ado. If I can find my slides here. There we go. Sound warning. That's always fun. Welcome to Chem 140. My name is Wes Hillman. I am your instructor for the winter 2021 term. My degree is in inorganic chemistry, and I have to yawn because I guess chemistry is boring. I don't know. No, I woke up earlier than I'm used to. Still adjusting to my new schedule. Please address me as any of the following. Any of these names is fine. It's mostly so that when you type in the chat, I know that you are talking to me and not another student. So if you have a question, just type Wes in front. You can call me by my first name. That's fine. Professor is fine too. I mean, it says Professor Wes at the bottom. I had a few students in the past who started calling me boss, and I was like, wow, I kind of like this. It gives me a feeling of superiority or something. I don't know. So I threw that on the list. And then I have the whole orc shtick that I do because I played World of Warcraft as an orc a long time ago, and it sort of stuck with me. So the only thing I just don't want you to call me, don't call me Mr. Hillman. It makes me feel old. Eventually, I'm gonna have to get rid of that part where it says I am only whatever, but you know. How do you get a hold of me for questions in this class? So, what you will be doing over the course of this quarter is watching lectures, doing assignments, working on Canvas, etc. Inevitably, at some point, you will have a question for me that you will need addressed. There's two ways to do that. You can email me at, I don't know why my office hours are in here. This must be an old slide. You can email me at whillman@everettcc.edu. You can also, let me get the pen out here, or through Canvas. You can also just go through Canvas, go to your inbox, and then send me an email. The best of these two options, oops, I didn't mean to draw a line there. The best of these two options is to email me directly by using, say, your student email. Or any Gmail account that you have. If you email me through Canvas, Canvas tends to have a little bit of a delay before it sends out a bunch of emails. And if the server is particularly bogged down that day, it might take a while. Oh, excuse me. If you send me an email through Google, it will generally get to me much more quickly. So that could be important if you're emailing me at, like, say, 12:30 at night. And I want to get an email to Wes before he goes to bed, and then the server on Canvas is just like chugging along because it's updating or something. I don't know. Don't worry about my office or office hours. Office hour will be I have to actually look this up because 140 is the class that I believe that it's Wednesday, but I thought yesterday I said Thursday, and then I got all confused. So we're gonna have a specific day dedicated to office hour, and that day is Wednesday. Okay, so it is on Wednesday. So ignore this down here. This is no good. we'll just ignore this. You're not going to my office. That's fine. Since this is an introductory class to chemistry, you'll be using Canvas for perhaps the first time. If you have not used Canvas before, excuse me, you are going to need to go to this URL right here. You can also access Canvas from the Everett CC main page. But what we're going to do is we're going to show a little bit about how this works. So I'm going to click here, and then I need to actually capture this window. So, boop. I didn't quite get all of it. Hold on. All right. So when you log into Canvas, and this morning when it did it again. So I hit login. I haven't changed my password. It says that my password's invalid. But we're going to try that again, and huzzah. Because Canvas, everybody. So that should be your first indication that, like, yes, something is screwed up with Canvas, and that's going to be our overall experience, I think. So when you log into Canvas, you'll get a screen that looks like this. You're going to click on Chem 140, which should be blue. It should be blue for everybody because I set the color. And then you're going to have all these options. Half of these you won't be able to see because I'm not a student. I have access to everything. I've hidden all of these options that you don't need to worry about. But the most important two options to you are going to be announcements, where I send out all my announcements to. These are the things that you get from emails. Oh, apparently someone commented on one. I didn't actually see that. And then the modules tab, which has all of the stuff in there. In the modules tab, the first things that you're going to want to do are you're going to want to grab the syllabus. That's what we're going to go over today. So when you click on this, it'll open the syllabus in a new window. There it is. And then the other thing that you're going to want to note is the orientation quiz, which will take you to the quiz page where you'll be asked a series of questions about the syllabus, about using Canvas, etc. Most importantly, of those questions, they'll direct you to use this link here to my YouTube page, which presumably is how you found this lecture anyway. Don't worry about this link right here. You can't see it because I have it turned off. Later on today, once I have the playlist corrected, I'm going to get rid of this where it says point to new, and then turn this on. And then you'll have a link to all of the videos for this class. That way you don't have to dig through my YouTube page to find that. So yeah. The next thing I'm going to do is I'm going to turn this off and then open the syllabus by pointing it to this, and that should be the syllabus. Is question 8 on the syllabus the one about like deadlines or rules or something like that? There's 2 questions on there that I hate Canvas quizzes a lot. And you're going to hear me complain about this all quarter, is that I can't make it be selective in the way that I want. And unfortunately, the only option that I really have, this is kind of small. Let me do this. We'll make it smaller and bigger. And in some cases, my hands are tied with Canvas. So, like, for that one, I was just like, okay, go ahead and try it again. It's going to tell you that, like, hey, you have all these correct answers, and then tell you the question is incorrect. And that just means pick more answers, unfortunately. There's really nothing I can do to get around that because the feedback you get is garbo for some of those questions. Don't worry about it too much. If you're having trouble with the orientation quiz, I can actually look at all of your answers and responses, and I can guide you. I can say, like, oh, you need to do this. I won't tell you the answer, but I'll tell you what or where to look for it. Those questions will be addressed in the syllabus here. So let's talk a little bit about that. So you should be able to access Canvas, no problem. Prerequisites are as follows. You need to be eligible for English 101 and Math 96. So Math 96 is intermediate algebra 2, I believe, or something like that. It's high school algebra 2, basically. If you qualify for that class, you qualify for this class. The math that we do is not difficult, but it does take some getting used to. We do applied math in chemistry. What that means is that in a math class, you would get a question that would be like x times 44 divided by 17 equals y, solve for y, if x is this number. Whereas in this class, that same question would be disguised as Bart the donkey eats 48 bales of hay every year. If a bale of hay weighs 17.5 pounds, how many grams of hay is he eating per minute? Like, that's the type of question that you'd have. It's literally the same question. You're just multiplying a bunch of numbers together in a specific way. But it's applied math. We're now taking all of that stuff and we're showing you how to do it as word. So it's all word problems, yeah. Everything in chemistry is a word problem. And at the start of this quarter, you're going to drown in word problems and be like, what the hell is going on? This isn't even fucking chemistry. And part of that is because we're trying to get a review of Math 96 in there before we actually do the problems that involve chemistry, and it totally overwhelms you because that's when the quarter starts to get really difficult. I want to say that that's like unit. I remember the old numbering. I'm gonna try and remember the new numbering. It's like unit 12 or 13 is when we start doing word problems with chemistry. But we're going to do word problems without chemistry, like convert feet to miles in Unit 3. So that will come up very quickly. So make sure that you've met that math prerequisite. If you have not, you may wish to delay taking Chem 140. If you're in Math 86 right now, you should take that first before you take 140. Otherwise, this might be a little bit too much. What do you need for this class? You need to have access to the internet. That is by far the most important thing. You need to have unrestricted access and not be on a data plan, because the amount of data that these lectures will take up will be absurd. If you're streaming through a data plan, you'll run out of data, and then you'll just be up shit creek without a paddle. Make sure that you have some sort of access to, like, I don't know, like cable or Fios internet provider that you can just watch videos and stream to your heart's content, because you're going to want to watch these during lecture time or watch them later. You could download them, of course, but that also takes bandwidth. And if you run out of bandwidth and an exam comes up, I can't help you. That's beyond my purvey. So you need to have internet access to take this class. So please make sure that you have that. And of course, it's an online class. I assume that you would know that, but I do have to say that. So, what else do we care about? The textbook that we're using is an OER textbook. Do not buy a textbook for this class if you don't want to. There is a recommended text at the bookstore for 140, and that text is a workbook that also contains lab stuff. Since we're not doing labs in person, I don't use the workbook. That said, the workbook has a lot of exercises because it was written by Samita. Samita is the other 140 instructor here. Her and I basically teach all the 140s. Occasionally we get a few other people that jump in, but I basically have piggybacked onto her book because her book is super good. And there's tons of practice problems in there that are actually really challenging. And if you want a lot of practice, you can buy the workbook and then do those problems. I have provided worksheets, which are sort of based on those problems, but they're different. So you'll get different problems than the workbook for the most part. I'm sure there will just be duplicate problems out of chance and whatever. But if you want the most practice, you can go buy that workbook. But again, that is optional. You do not need to buy that text at all. No text is required for this class because we're going to be using an online book. If you go to Canvas again, let me go back over to this screen. And that's really big, but that's okay. We'll just cover the chat up for a second. if you scroll down, you'll see that I have a list of slides and then a list of like recommended links for reading. So if I click on this, it will tell you what to read for each section in my slides. So my first slides that we're going to do today for Unit 1 is just like, what is science? What the hell are we doing science for? How do we do it, etc. And there's a list of things that you should read. So for example, you click on this, go to the link page, and you read sections 1.1 through 1.4 and the first half of 1.5. That'll cover the first section of my slides. And then the second section will be the second half of section 1.5. And then there's other things that you can read. Any videos that we're going to watch today, you can't see it because it goes down further than the window allows, but that's okay. Any videos that you see are going to be linked on this page. Let me just get that available. Oops, that's not what I wanted. I want to make this smaller. Oh, no. Oh, no. Oh, no. Hold on. I may have ruined it. I may have ruined everything. Oh, wait. No, it came back. Why is there... oh, that's my timer. Never mind. Okay. I have to delete this filter. I accidentally shoved it off the side of the screen and I can never get it back again. So I want to window capture. Oh, for fuck's sake. Sorry, OBS is being obnoxious. Is that what I want? Yes. So that should be... yeah, there we go. So you can see... oops, sorry, wrong button. Ah. You can see at the bottom here, down here, these are all links to videos we're going to see in the slides for Unit 1. All right, so let's get rid of that. I got to put the syllabus back on the screen here. There we go. Okay. What else do you need? The last recommendation that I would have is to have a calculator that is capable of doing what I would call functional algebra. So a calculator that can do natural log, base 10 log, exponentials, 10 to the power of, things like that. So you're going to want a calculator that's at least scientific in nature. You don't want a desk calculator that just has plus minus times divide. You need a little more heavy duty than that. If you need a calculator, you can use your Windows calculator. It's just kind of tedious. You can also use your smartphone for that. But the best option that I would recommend is right here. It's Wolfram Alpha. So if you click on this link in the syllabus, I'm trying to copy the link here so that I can paste it into the chat for you guys to have here. So if you click on Wolfram Alpha, and I'm actually going to go to this link here. You know, let's just get another window capture so I don't have to play with this more. That's going to put a timer in the corner. Ignore that. Let's see here. So let me make this smaller really quickly. There we go. So this is a very powerful computational tool that you can literally have it do any sort of calculation that you want to. So what I'm going to do is I'm actually going to have it do this. So like 2x plus 5 equals 11 and, oops, sorry, 5y equals 11 and 4x minus 3y equals negative 29. And I'm going to just have it solve this system of equations. So it's thinking, and there you go. So this is the result that it got. It's plotted it on a graph. Like, it does all sorts of stuff, and it did it in like 2 seconds. So, like, if you are trying to solve a calculation problem on your calculator. It takes a long time to punch it in there. And if you make a mistake, it might be really hard to diagnose. If you type it in on Wolfram Alpha, it might immediately find it. And also, it's very fast for typing in like functions and stuff like that. So if you don't have a calculator, I would recommend this. The downside to using this is you do have to type stuff out on a bar, which can be kind of weird. And then finally, the last thing I would recommend is you need a periodic table of some sort. The link that I have available is, I'll just type this one in, ptable.com. There we go. And if you go to ptable, then what you get is this. And that I had to make that one smaller. Oops. So you'll get this nice little periodic table website that will have all this information for you that's super handy. And we're going to be using all of this throughout the quarter. So just having those two links bookmarked will be very helpful to you as the quarter progresses. All right. Those are the things that you will need to be successful in Chem 140. All right, let's talk about other expectations and stuff like that. Like, what are we going to do? When are we going to do it? So here's our schedule. Our lecture schedule is Tuesday and Thursday. I mistakenly said Tuesday and Wednesday in the video yesterday. I apologize for that. In hindsight, I probably should have done Tuesday and Wednesday, but this is what it says in the syllabus, so we're going to go with this. So what that means is today we have a lecture, and then Thursday we will have a lecture. But tomorrow we would normally have a lab meeting. There is no lab during week 1. I just do them on even-numbered weeks, so nothing tomorrow. So the next time we will meet after today is Thursday. Then the second week we will meet all 3 days, Tuesday, Wednesday, Thursday. During lecture time, we're going to go over slides and practice problems. During the lab lecture and question and answer session, I will go over a laboratory worksheet, so we're going to talk more about the lab next week on Wednesday. Or I will just answer any questions that you might have, or we'll do more exercises, or we'll work on the practice worksheets, or whatever. That time is generally used for you guys asking me questions, and if you have anything, I go over it. If we need to, because the class is falling behind in like lecture content, like we're spending too much time on stuff and we need to get through it all, I'd start to turn those into lecture days, and we'll just go over more content. Last quarter, I didn't actually have to do that, surprisingly. But the fall quarter is slightly longer, so we might have to turn 1 or 2 of the days into that, and I'll try and let you know that, like, hey, it's going to be a lecture, make sure to come. So just be aware that that is a possibility that exists. As you can see over here, this is the chat window. You can type anything you want. Anything you want. Hooray. In the chat window. And it appears in the video. The reason that I do that is because YouTube doesn't always allow people to replay the live chat. Some reason, like when I view it, it doesn't show up. Like, I think it shows up eventually, and I believe I have the right options toggled, but just to sync up what is in the video with what I am saying, I have put the chat log on the view itself. What that means is that everything you type in there, it does get recorded onto the video, and everybody will see it. So obviously don't say anything that you don't want to say. You can redact any message that you want by clicking on the little dots. So you can retract a message, you'll just pop that up. Whatever was there will stay there, so people can go back and look for it. If they want to, like, pin through frames or whatever. But most importantly, don't say anything that contains either personal information that you don't want out there, or anything that's derogatory. So anything that looks like it might be insensitive or offensive to other people, or beliefs or backgrounds or whatever, I squelch. So I would go in and just delete a message and get rid of it, and then I time that person out. And if I time a person out enough and I remember their name, I ban them. If you get banned from my chat, you also get banned from all the lecture streams. Don't do that. That would be very bad. If you can't see the lectures because you are an ass in chat, sucks to be you. Don't do that, okay? I have to keep that in place because don't be an asshole is a philosophy that we should all strive for. So just be mindful of others and treat others as you would expect to be treated, and there won't be a problem at all. I have never had a problem with it other than the occasional weird troll. That was very clearly not somebody in my class. I had somebody come in who claimed to be a famous porn star and asked a question that was actually about the content of the class. And I immediately banned that person because that's inappropriate, even though they were actually asking a question related about the class. So these videos are public. Anybody in the world can come and watch me lecture, because if I don't set it to public, I don't know if you guys can find it if you aren't subscribed to me. And I don't want to require anybody to subscribe to me. So what I do is I put it on public, but it's unlisted. Maybe it's not unlisted. It's probably just public, so anybody could come in and find it. But I am very on top of just muting and banning trolls. And if that happens and you happen to not be a troll and you're actually a student and you're just being a jerk, I will ban you. So don't be a jerk, basically. That's basically what this part is saying. Like, please be mindful of etiquette. Let's talk about policies for attendance and then what you're going to do in this class. So I really need to clear my throat. Let me drink some more water real quick. So I know that some instructors have an attendance policy. I think that for an online class, that is absolutely ridiculous. There is no attendance policy in my class. I have no expectation that you will be able to make my class every single day during a pandemic when at any time or any moment everything can go crazy. That is an unrealistic expectation. I will archive these lectures for you in YouTube, and they will remain there forever. And you can watch them whenever you want to, as long as you watch them at some point during the quarter so that you learn the material. Other than that, I have no expectation of you to attend at any given time, with very few exceptions. Those exceptions are the 2 exams and the final. And even then, I say take it sometime today. You do not ever need to be here for a specific hour. You do not ever need to be here for a specific purpose, except for those exams or the final. So this class is completely open-ended. I leave it up to you to pace yourself at whatever pace you want to. But I will put out specific deadlines for certain content at times. So make sure you are staying on top of the schedule, which will be posted on Canvas. It's also at the bottom of the syllabus. Make sure that you are paying attention to deadlines for things like quizzes, labs, and the exams in the final, because those are the 4 things you're graded on. The first category we're going to talk about is homework, and I'm going to talk about it separately because homework is the only ungraded category. This is college. Homework is not something that you turn in for points. Homework is something you do so that you learn the material. Okay? So what that means is that I'm going to give you a series of problems. The only reason that you would do these problems is to learn the stuff. If you have learned the material and you feel confident about it, you don't have to do the problems. It's not worth any credit, and you're not turning it in. If you don't feel confident, do the exercises. You don't become an Olympic-level athlete by watching Brian Boitano skate around an ice rink for 20 minutes. The same reason that you don't become an expert at dimensional analysis by watching me do 2 examples. If you just sit there and watch me and go, oh, that looks easy, and then you do no further work, you're going to forget, especially when it's important. Make sure that you are putting in the effort so that you develop the muscle memory and the routine to do the content that we're going to talk about. Okay? Homework will come in 2 forms. There will be exercises in the OER text that I recommend, so those pages that I showed you earlier, And I also give you a worksheet. The worksheet is probably the closest to what the quiz and exam problems will be like, but I also recommend doing extra practice from the OER text as well. The first form of assessment that I will grade you on are quizzes. Quizzes are nefariously the hardest content you do in the class. And the reason for that is because it's the first time you will see it on Canvas. Let me set up the groundwork for how you do quizzes, and then exams and the final will also follow suit with this. First of all, a quiz is given on a unit or set of units. For example, the first quiz will be units 1 and 2. And it will unlock once we have completed the units relevant to that quiz. So for the first quiz, when we finish unit 2, I will then say, okay, a quiz will now be unlocked. You have a week to do it. And I'll hit a button, and it will open up, and it'll start counting down to a deadline. And you finish it before the deadline. We'll talk a little bit more about deadlines in a second. The quizzes are going to be like the orientation quiz in terms of style. There's going to be questions where you have to type in numbers, where you have to check a box or multiple boxes, click on a picture, that sort of thing. The difference between the orientation quiz and the quizzes that we'll be taking is that when you perform the quiz and you submit it, you will not get any feedback on how you did at all until everybody has turned in their quiz. Now, I do give you multiple attempts per online assessment. So on a quiz or the exams or the final, you get to take them twice. You don't get a score for the first attempt. So if you feel like you did the assessment poorly, you're like, man, I didn't know how to answer half of this question, so I'm going to go study and then take it again. That's fine. I'm perfectly okay with that. That is absolutely acceptable. If your computer crashes during your assessment, or the power goes out, or Canvas goes down and you lose all of your time or whatever, that's why I have 2 assessments in there. So I give you 2 opportunities to do it in case that happens. It's not going to happen twice. If it does, you should email me, but it's very unlikely it's going to happen twice. I cannot give you extra attempts for any reason. Make sure that you are doing the attempt with enough time, you don't have any distractions, etc. Okay? The 2 attempts per exam or quiz is mostly there in case of hardware failure or internet blackout or something weird like that. Okay? But I cannot give you extra attempts for any reason. The time limit for quizzes is set in such a way that if you know how to do the content, you can do the problems on paper very quickly. You can do it in like half of the listed time. If you are referring to notes, and you'll notice here that it says right here highlighted, you may use anything that you want on a quiz. I can't stop you. You can use your notes, you can use other people, you can use the internet, you can use the text, but the only thing you can't do is email me, because I won't answer any questions about a quiz until the quiz has been done. You can do anything regarding your quiz that you want to, but you have to do it in the time limit. The time limits are set specifically that if you are not on top of the content, then you're going to run out of time. Okay? So be comfortable with the material. Make sure that you have studied well before you actually take the assessment. Okay? I know a lot of complaints in the previous 140 class that took this, and a lot of them passed. They did really well. A lot of the complaints that I heard were, wow, there's just not enough time, and I don't have data to support that. The data that I have from my A students and the students that I knew understood the material, they did it in 2/3 of the time limit. I can do it in about 1/3 to 1/2 of the time limit, and I teach the class, so of course I can do the problems really quickly. But I have set up the time limit specifically for that reason. So when you get to the end of the quarter, you're like, man, there isn't enough time. Take that as a hint that you need to study and prepare more. Okay, make sure you're doing as many examples as you can. I believe that is everything regarding a quiz. You're going to have a bunch of questions. There will be a time constraint. You can use any resource that you want to, but be mindful of the time limit. I had questions come up, but I was in the middle of that, so I'm going to get back to them. If you have a question about homework, Wednesday is the time to go over it. Specific homework problems that you want quickly answered, you can always email me. During class, the focus is for me to go over the lecture material. So I can't answer a ton of homework questions during the lecture. So like if you had a question right now for homework, I would ask you to email me about it, or we'd answer it tomorrow. This is not a question and answer session. This is a lecture for a class, so I can't answer your question. All right, so that is quizzes. Let's talk about exams really quickly. Exams are basically quiz questions that are a little bit more complex. There's a lot more of them, and you have a longer period or interval to work through them. Exams are cumulative and cover all of the content from the start of the quarter to that exam. So exam number 1 will be units 1 through 8. Exam number 2 will be units 9 through 16, but it will still have content from 1 through 8. You still need to know it in order to be able to answer that stuff. I give you a longer amount of time. Same restrictions as on the quiz. You can use any material you want. You can use any resource you want. However, you only get 75 minutes to do an exam, and if you spend too much time dawdling, you will time out. You do get 2 attempts. The only differences between an exam and a quiz are, besides like the time differences and number of questions, are things like, 1, I don't publish the answer key to an exam. You'll never find the answer key for it because it won't be posted. And number 2, oh, excuse me. What was number 2? Crap, I had it in mind. I can't think of it right now. I don't post the answer key for the exam, and that's really all I can think about for that. Yeah, I don't know why I had 2 reasons in mind. Okay, whatever. Something that I forgot to mention before for quizzes and exams is that for the quizzes that you will take, you will be given a series of questions from a pool of questions. However, you will not get the same questions every time, and you will not get the same questions as other people. So your questions will be similar in nature, but they're all drawn from pools. So your quiz and your exam, and then the final is pseudo-random. There will be variations on it. The numbers will be different, etc. Okay, so be mindful of that. Don't just share answers because you will get the answers wrong. I'll just tell you that right out. Like, I don't care if you share answers or at least strategies or whatever. Like, it's a pandemic. My expectations for like what you will accomplish in this class are different. Like, it's not realistic for me to like completely expect that you're isolated from everyone else, online and offline. I like no. Work together and study together, but be mindful that you will get different assessment from each other. So you can't just pass the number 74 to your friend and tell them to type that in, because they will get the wrong answer even if yours is right. Okay, be mindful of that. Final exam is just like the exams, but longer, and it's the entire quarter. I don't release the key for the final. You'll get your scores once everything is graded for each of these things. Any questions about assignments? We're going to talk about laboratory separately in a second here. Whenever I ask you guys if you have questions, I had to have an awkward pause or fill like a minute of dead air, because the amount of time that it takes for me to get my voice to get to your side of your screen, and then for you to type out a question, and then for that question to get back and pop up on my screen, is somewhere on the order of 20 to 30 seconds. So I have to give you a second to think and type out a question. So if there's just like a long, awkward pause, that's what's going on. I'm waiting for questions. With regards to questions, ask me a question at any point, and when I get to a pause in my conversation, I will be able to answer it. So, like, for example, a question just popped up. Are there answer keys for the worksheets? There should be. If there's not, let me know. I will post those. Those will be available on Canvas. Let's see here. Let's talk about lab very briefly. The whole point of us talking about lab will be that we do this on the lab lecture days, which will be Wednesdays. We're going to do 5 labs. They'll be during weeks 2, 4, 6, 8, and 10. We're going to talk about what we will do on those Wednesdays. So Wednesday week 2, which is not tomorrow, but the next week tomorrow, we will do this lab. We're going to talk about the observations lab. We'll talk about what you do in the lab. I'll show you how to fill out the worksheet, how to submit the worksheet, etc. And then we'll do a Q&A where I just go over practice problems. There are no lectures on Wednesdays unless I turn it into a lecture. Will there be answers to the assignments, or you look at them when they're complete? There are some answers posted for some questions in the online text. I believe it's like every odd problem. So you can compare to that. A thing that I would definitely recommend, though, is that you develop confidence in your work, because if you do problems, at some point, you need to be able to do the problems without expecting the answer, because that's what you have to do on the exam, right? So on a quiz or an exam, you're going to punch everything into the computer, and you're going to hit enter, and if you are so overcome with terror and fear that you don't know the right answer or if it's right, then you're not going to be able to continue the rest of the exam because you have like 20 more of those problems to do. People treat it differently on an exam, and I realize there is a difference between that and the homework, but as you do the problems, what you want to eventually do is get to the point where you can do these problems and then be confident that you did it correctly. If you can do that, you have studied sufficiently. So that's a really good question that you brought up. And that's the feeling that I'm trying to get you to work towards. If you do anything enough, you will become confident at it. And sure, eventually, or sure, at first, you will need the answers, and that's fine. I will provide as many as I can. If you have a homework question and it doesn't have an answer, and you really want to know the answer, send it to me. But if you send me like 17 problems and ask me to give you answers for all of them, I'm only going to give you 1 or 2. Because I just don't have time to do 17 homework problems for you. Let's talk about late work. Don't turn in things late. There is a deadline that will be posted. If you miss the deadline, you miss the points. That's it. Easy as that. Now, to make things easier on you, any assignment that is not an exam or the final, so those are one-day special things, we'll talk about them later, will have a deadline that is posted with about a week in advance. So that includes lab worksheets and quizzes. I will post the deadline and say, okay, you have a week to turn this in. Ready, set, go. And you take it whenever you want to. And when the deadline passes, the assignment will stay open for 1 additional day. Canvas will flag your assignment as late, and I ignore it. The reason that I set the 1 day ahead of time deadline is because everybody waits till the last second anyway. I know this, I do it too. And then having that extra day is like, oh, I have an extra day, okay. And then you can work on it through midnight or whatever. So for for quizzes and the labs, I will post a deadline, and then the following day I will say, okay, last call, get the assignment in by tonight. So you'll have the deadline, my announcement, and then the final deadline to get it in. So the initial deadline is what is called a soft deadline. Please do this by this time, but if you can't, you still have a day to do it after that. The day after is the hard deadline. If you miss the hard deadline, you get a 0. Do not miss the hard deadline. Excuse me. For exams in the final, there are only hard deadlines because you only get 1 day to do them, not 1 week. For example, there is a date for exam number 1. It'll be like Monday, week 6 or something like that. I open the exam for the entire day and I send you an announcement. The exam is open. Do the exam today. It closes at midnight. That's your hard deadline. If you don't do it by then, I don't give you credit for it, and that's obviously very bad. I do not allow makeup anything. So if you miss something, you miss it. If you didn't realize it was due, it's too bad. Pay attention to the deadlines and the announcements I send you, because I will be sending you constant announcements, okay? You got to take responsibility. You got to be on top of it. I know that there's going to be a lot of stuff going on, and you have to find a way to manage. Now, the last part is sort of remember all that stuff I talked about? Like, you got to do this, you got to do this. Well, here's one instance where you can miss one thing. So I have an NQA policy for all the classes I teach. At some point, something slips by and you inevitably make a mistake. I give you one forgiveness, basically. And what that means is that if you miss a hard deadline, tell me, oh, I want to use my NQA, I want to take the quiz later. I just couldn't get to it this week. That is fine. You can do that exactly one time. I flag it in my gradebook that you have used it. If you try to use it multiple times, I give you a 0 for the class. Do not violate the NQA policy. You get one forgiveness. If you don't use it, you don't get anything for it. So make sure that you are aware that this exists and use it as your backup plan, okay? This is to cover you in events where it's just like, oh, you have too much going on and you can't handle all these deadlines at once. I need to work on this other class. I'll do this later with the NQA. That's what it's for. What this is not for is for emergency stuff like that. If you have a valid emergency, like I had to go to the hospital or whatever, something like that, that's like a valid emergency, send me a document that just says like where you were and what happened, and we'll work from there, okay? So I'm not going to be such a hard ass that like, oh, I'm sorry that your dog died, the exam's still due. Like shit happens, right? Like really, really awful things happen that go beyond the NQA. The NQA is just, I am overwhelmed. I need an extra day. Now, how do I differentiate between these two things? NQA is no questions asked. I let you do whatever you need to with the NQA policy for one assignment. If you aren't using the NQA, I require you to document what's going on. So if you were in the hospital, I'm going to need your hospital to send me a paper that says so-and-so was seen today. Please excuse them from whatever assignment, okay? Because otherwise I would just be taking your word at face value, and I would have to assume everything you're saying is true, which unfortunately is not a position that I can take. So if you have an extreme circumstance and you can provide documentation for it as like an alibi sort of thing, I will work within that too. Otherwise, you have the NQA policy for one incident that you just need a breather. Here's how many points are in the class and how the points are broken down. There's going to be 9 quizzes. There may be 8. I may reduce the number of quizzes by 1 if we get to the end of the quarter and there's just too much work for you to do. I don't want to pile a quiz, an exam, and a lab and a final all on the same week. So I might change that. We'll see. But the number of points will be about 500, and this is the point breakdown. Your score is scaled to this and nothing else. I do not raise your grade because everybody did poorly, nor do I lower your grade because everybody did well. Your grade is strictly a percentage of the number of points that you got, and that's it. It has nothing to do with how many lectures you attend or how active you are in participation or sending me emails or whatever. Like, I can like you as a student, but it doesn't affect your grade. So the only thing that we care about are points, and your points are going to come from these assignments and these things that are right here, okay? So what that means is that you can all work together and you can all get an A. That is possible. I do not curve the class so that the average is a C. I just don't have enough people that is ethical. So, yeah. As far as points are concerned, your points are the total number of points you've earned divided by the total number of points available. That formula is shown down here. Keep every assignment that you have completed. Obviously, it's a virtual class, so that's easy. It's all just going to be stored online. And any lab reports that you submit to me, I will send them back with a score on them. You should be able to compute your grade pretty straightforward by just using this formula. Canvas will do it too, but Canvas might mess up. But Canvas is not a good grade book. Do not rely on Canvas to tell you your actual grade, because there may be other caveats involved. Lastly, there is no extra credit. Do not ask. I do not give extra credit assignments. I do not give extra credit worksheets or homework or anything like that. The only extra credit that is available is on the exams and the final. An exam is out of 75, but there will be 83 points possible. If you get every question right on the exam, I'll give you 83 instead of 75. And if you get every question right on the final, I'll give you 165 out of 150. So you do not need to get all of the questions right on the exams or the final to get a perfect score, which would be 75. Anything that looks like it might have been graded in error on Canvas, please let me know immediately, because it will likely affect the entire class. Please review your assignments once you have received your score on them. You can do that by accessing the assignment and going into the quizzes. If you're taking it again, it'll show your answers and your score. Canvas will partial credit on most things, but some it will not. If you got 5 out of 6 on a question, but it gave you 0 out of 1 points, I can't help you, unfortunately. That is a gimmick that Canvas does for certain questions. I try to use those questions sparingly, but please do not ask me for fractional points on a question that Canvas zeroed out, because I can't manually do that for all students. It would take me 96 hours to do, and I'm just not willing to do it for 1 point. If you see any issues on like your lab, like, oh, these points don't add up, let me know. I will fix those. I am very amenable to fixing scores, especially if they are like Canvas had the wrong answer as the correct answer or something like that. But if you're asking me for more partial credit without making any changes, generally speaking, that's not going to happen. Okay. As far as grades are concerned, in terms of not getting a letter grade, if you take a withdraw after week 2 or 3, it puts a W on your transcript. If you withdraw after week 8, I put a V on your transcript. They're essentially the same thing. That just means you drop the class. Don't worry about it. I don't authorize audits for any reason. Yada, yada, yada. None of this will probably come up unless you choose to withdraw from the class. And at the end of the quarter, you have to let me know about that anyway. We could talk about that on a case-by-case basis. Finally, we've got CDS stuff. If you have a CDS accommodation, let me know. I will make the adjustments on Canvas, but I need to have that form from Canvas sent to me so I know. And then academic dishonesty and the academic honesty policy. As a student, you are bound to the academic policy handbook for students. You can find that at this link in the syllabus. Specifically for this class, what I care about is plagiarism. Don't turn in the same lab report. If you have 2 people turning in the same lab report, I don't know who did it. I can't assign credit. I don't give any credit. Obviously, I want you to work together, because these are science classes. They're difficult, and you don't want to go it alone if you don't have to. So forming a study group is great. Working together on assignments is fine. Asking each other questions and passing information back and forth is expected. But what I don't want you to do is, hey, I did the lab. I'm going to send it to you. Just change your name and then upload it, because that will get you both a 0. Okay? You have to do your own assignment. Just like with the quizzes, you have to do your own assignment. I can't randomize the labs because Google Sheets won't do that. But you do have to write out your observations in your own words and so on. Because this is an online class, you're going to have to put in the effort, and the experience that you get out of this will be proportional to the effort you put in. You're responsible for your own learning experience. So what that means is that if I show you how to use a screwdriver on a bolt to remove it or whatever, I can give you the screwdriver, I can put it in your hand, and I can show you how to do it, but I can't make your hand do the moving motion to torque the screwdriver. You have to do that yourself, in the same way that I can talk about dimensional analysis and solve a problem, but then you have to be able to do it on your own too. Okay? Make sure that you are following along with the content. If you start to fall behind, that you email me or ask a question so that I can address it, and we can get there together. I don't want you to fall behind, because if you do, it gets harder and harder and harder to catch up. The more stuff we stack on top of the foundation of chemistry that we're going to be doing, the harder it gets as the quarter progresses. I want this to be all on the screen, so I grabbed the wrong window. There we go. This is our schedule. You can see that there's going to be no lab Q&A session tomorrow, but every other day will be a lecture or a lab. All the lectures are on Tuesdays and Thursdays. Lab Q&As are Wednesdays. Every other week is a lab Q&A. Note that the lab assignment is due a week after the lab is assigned. And so if you're ever curious about deadlines, just look in the syllabus or on the Canvas calendar. This is an approximate order of what we're going to be doing. There are 16 units in this class. Some of them are extremely short and others are not. Like units 4 and 5 should really just be rolled in with a different unit, but they're not. So let me talk about this class just a little bit, and then we're going to take our break because we're at about the top of the hour of the class hour. The class starts off with a heavy emphasis on math in units 2 and 3. We're going to spend a good part of our first few weeks doing math from units 2 and 3, and then also a little bit 4. And a lot of students struggle because it's all dimensional analysis. Then we're going to do this huge part of the class where we don't use a calculator at all. And that part of the class, generally speaking, is easier because it's conceptual and people like it, and we do other stuff. And then all of a sudden we pull out the calculator again, and then it's calculator city until the end of the quarter. And the class gets really, really difficult. So the big hiccup points for this class are going to be weeks 2 and 3. With a little bit of Thursday, because Chapter 2 and Chapter 3 are where people get hung up on. And then from the end of week 7 onward. So, be very careful about this class. It is sort of a sleeper. It starts off a bit challenging, and then it gets easy, and then you'll let it slip into the background. And then we're going to get to the end, and that's where it gets you. Okay, so be really mindful of that. I like to tell students where to watch out for, because the worst thing that happens, and I've seen this so often, is people struggle on the math, and then they're doing well all the way up to about here, and then we start doing math again, and their grade goes from a B to a D minus, and they don't pass the class. And they're like, why did this happen? This class is so easy. And the answer is, well, we do a lot of math at the end. And if you aren't prepared for it, then that can happen. Okay, so be mindful of that. Any questions, let me know in the chat. What we're going to do now is, because this is a 2-hour class period, every hour, I take a break. That's not the break window. There's the break window. I start the music and I start the timer again. And when this timer goes to 10 minutes, I will hit stop on it. And then we will resume. So if you are like in the hallway or wandering around, you look at your screen, it still looks like this, it's still on a break. If it looks like this again, then we've gone back to our lecture and we're going to talk about lecture content. So come on back to the computer, okay? So I'm going to put the break timer up here. I'm going to start the timer. And then I will start the music. And we'll get back to it. See you in 10 minutes. That's close enough. Let me wind the music down here. Right. So, I don't need this. We've gone through the syllabus. Let me click off of that so it's not in my way. Just some last little information here. Students often ask, like, what's the best way to ensure that I learn the material in an effective manner and use my time wisely? And so I put together this slide to try and guide you into a set of habits that will promote success. Now, this won't be the way that works for everybody, and you should obviously try and find what method works best for you. Excuse me. But that said, some students asked last class period, actually, in 131, and we came up with this method before we even got to this slide. So it seems like people have this idea sort of in mind, but let's reiterate it anyway. What you want to be able to do when you come to a lecture is have some background. And in order to do that, you'd have to read the material. So the first step is to read the textbook, which in our case is the OER. Read the linked sections and write some stuff down, like maybe take notes on it, maybe try and do 1 or 2 problems, write down stuff that's problematic, like, oh, I don't understand what's going on here, and that's fine. Then when you come to lecture, we're going to do the lecture. I will talk to you about the topics. And then if something comes up that doesn't address your questions, then you ask me those questions. Print the slides out or have them available on your screen so you can write all over them with the tablet. Do whatever you want to with them, but use them as a resource. After the lecture, then go and do as many problems as you can that are related to the homework for that section. You do them by yourself, you do them with a group. People tend to do group problems pretty effectively for 140. I had a group of 140 students back when we were actually at the college, and they would just do their evening ritual would be from 4 to 5 before the 5 p.m. class started. They would all do homework problems, and they all got A's. So if you develop a routine and put in the time and the practice, you'll be successful in this class. Now, how much time do you need to actually put in for a 5-credit class? Well, we've done the calculations for that. We have data to support this. And the amount of time that is required in outside prep, so not counting the lectures that you're going to do, 2 hours a day. 2 hours a day will get you to the level of competency that will get you a C in this class. Now, nobody wants a C, obviously. So in order to be better than that, you'll need to put in more time. Now, you might think, I don't have 2 hours a day. I'm already here for 2 hours. I got to put in 2 more? Yeah, you do. If you want to become an expert, and what we are doing in college is training you to become an expert in these classes, is you need to put in enough time to be able to do that. Now, there are other things that are going to be competing for your time, obviously. You might have to work, or you might have family or dependents or something that you have to care about. Or maybe, like, you have other classes. All of these things eat up time. If you don't have enough time to be successful in this class, I would strongly recommend that you either drop other classes or drop this class or whatever it takes to organize your life. Because one of the major things that students run into in taking online classes over this pandemic that I've found is it's too much. I have too much going on. I get countless emails through the quarter where I just get students who say, I thought I could do this, but X happened and I just couldn't acclimate to it, and now everything's falling apart. I need to drop the class. And by then, it's too late to get a refund. For 140, most of you are probably running start students, so I believe your tuition is already covered. So that's good. You don't have to worry about the monetary aspect about that. But the mental stress aspect of, I have so much shit going on and this is just all piling up and I can't deal with it. That's not a good situation to be in. So make sure that you are in the right state of, both state of mind and also state of capacity, I guess we'll say, to be able to handle a 5-credit course. And if you're not, and you aren't sure if you should take the class, come talk to me over email and I'll address that in private. Okay? Because the last thing I want to do is we get to week 8 and then people just start dropping because it got to be too much. Okay? That's all I have for the intro. So let me get the chapter 1 slides. So the screen will just go black for a second. And then I do this. And it should just pop right back up. There it is. All right. All right, those are just the introductory slides. There's not really super detailed information on there that you need to write down. These are the actual slides for Unit 1 that if you have completed the orientation quiz, you have access to now. And Unit 1 is very simple. It's just, what is science and why do we do it and how do we do it? We're going to talk a little bit about that today, and I'm going to show you a bunch of YouTube videos of various stuff. We're going to see if we can get my account copyright striked. Not really. I'm going to mute certain videos because I know I got copyright claimed for them last quarter. Particularly one from the BBC about a feather and a bowling ball in a vacuum. All right, let's talk about science. What is science? Science is all sorts of crazy stuff. And it's sort of this name that we have given to wide swaths of things. So, for example, right now, vaccine research is very, very important because there's a pandemic. How do we get to what a vaccine is? Well, we need to understand what a virus is. How do we understand what part of a virus we can prevent? Well, if you know biochemistry and how molecules are shaped, you can then design something that recognizes those shapes as a template. And then you can use that template to make your RNA vaccine that your antibodies in your body will discover, and so on and so forth. And you can tell by looking at that statement that I just said that rambled on and on. Each of these things is a field that you could just investigate. Like, okay, what is a virus? What is a protein? What is RNA? What are atoms? What is matter? Like, these are all questions that we can ask. And the way that we get information out of that is by investigating it in a clear and controlled manner. And so that's what science is. Science is the means by which we gather information to explain what's going on in the world around us, but it's performed in a manner that we can both reproduce it, we can both explain it, and we can both understand it. So the difference between science and something that is not a science would be something that's subjective. So, for example, an opinion about something that you would maybe write like in a newspaper article or an online blog or something like that. That would not be science because we can't reproduce the information in that or test it or whatever. So we're going to split what we can study into two things. Can we test it and reproduce it, and what can't we do? And we're going to focus on just the stuff that we can test. So that's what science is. Now, there's a bunch of different sciences out there, and they tend to end in G. GY, I mean. Like technology, biology, geology, astrology. And then we get chemistry, which doesn't end in G. Y, for some reason. But that's what we're studying. Chemistry is specifically the study of matter and how it interacts with other matter. What I mean by that is if I take substance A and I put substance B on top of it, what will happen? Sometimes if I put two things together, they react. Sometimes they don't react. Depending on what our application is, we will want one over the other. For example, if I am trying to alleviate an upset stomach, I will want something to react with my stomach. So if I consume something and nothing happens, that's not an effective treatment for my condition of upset stomach. However, if the application is I want something to sit on, the chair that I have constructed better not react with my clothing. Otherwise, that would be a problem. So reactivity is important, but also lack of reactivity will be important too. And that's what chemistry is. We're going to study why things do what they do and then how that ends up happening at the molecular level. So how do you science? If science is just, oh, we need to organize a way to do research, then what's the theory behind that? And it's actually really straightforward. Scientific research requires us to investigate a specific topic or question that we select. And the goal of that is to discover information. For example, maybe I don't know what calcium does. I want to examine all of the properties of calcium. And so I could learn that it tends to have a +2 oxidation state. It tends to form white, brittle solids. If paired with certain other compounds, it forms white, solid solids. Like, it's very sturdy. Sturdy was the word I needed, not solid solids. And it's insoluble in water in most cases. So, like, these are all things that I could find out about calcium. Those would be scientific research. Those are just sort of a random collection of facts. Not super useful on their own, but interesting, and I guess if you like trivia. Okay. Once we have done scientific research, what we're going to do is we're going to then apply that information. Oh, I'm sorry. What we have done is basic scientific research. We have taken various factoids and gained them. We're going to then apply those. We're going to take applied scientific research by using the basic science that we just discovered and then set it to an application. Okay, if calcium is insoluble in water, could I build stuff out of it and then put those buildings outside? Yes, because it wouldn't dissolve. So that would be an application. If calcium forms really sturdy solids, could I use them to make things like teeth and bone? Yes, that would be useful. If calcium has a +2 oxidation state, can I combine it with, what things can I combine it with? How about oxygen? It's in a -2 oxidation state, and those will cancel. Like, these are all applications of our basic information. Okay, so we're taking these simple facts and we're making uses out of them. Once you have made the application, you're going to want to develop some sort of thing that the rest of society that isn't scientists can use. For example, me making building materials is not super useful to people. They want the building itself. So once we have taken the applied science and produced a product out of it, we call that technology. Now, if you play Civilization 6, all of your tech tree things are technologies. These are all end products that I can hand to people. Now, you might not think that astronomy is a thing that I can pass to somebody, like right here. But in reality, like, I can give the concept of astronomy as, like, I can see where the positions of things are in space and then determine relative positions to other things near them to see how far away we are from them. And here are those applications. So that could be a technology in and of itself. I just put that picture up there for fun. But technology is like a tactile thing that people can hold in most cases, or it's a concept that helps revolutionize how society functions. For example, agriculture is a very important technology. Agriculture is the concept of, oh, if I plant food in a specific spot and then harvest, water it, and then remove all the weeds and make sure the soil is well fertilized and has nutrients. Those are all like important things that required work and research to do. Plastic is another good example of technology. I can hand you plastic. Here's a plastic bottle. You can store stuff in this. It will be safe because you close the bottle. Then nothing gets out. The plastic is insoluble in everything that we try to pour into it, so you can store whatever you want. It won't destroy the plastic. Like, these are all examples of technology. So on a given quiz or exam, you might be asked topics about basic science research, applied science research, and technology. And the things that you're going to want to remember are that, let me just clear this really quickly so I have a space to write here. So remember that basic research is just, I'm going to write random and I'm going to put it in quotes. And I'm going to write this very specifically like this. Basic research is the sort of stuff that you look at and you're like, that's cool, but, huh? Like, it doesn't seem super useful to you. Like, if I told you that I can dissolve gold rings with this specific acid that I have, you might be like, why would you want to do that? Gold rings are cool. They're jewelry for people. So that would be the basic research. Like, oh, I know that gold is soluble in aqua regia. And you might think of that as just like, why? Why is that important to me? The why it's important is the applied research. And so this is going to be, we'll say that it applies, hence the name, basic research into something practical. Why would you want to dissolve a gold ring? Well, maybe you don't want to dissolve a gold ring. Maybe you just want to dissolve gold. So here's an ore that has some gold in it. I don't want the other shit. I just want the gold. Okay, drop it in. It'll dissolve the gold out. The rest of the stuff won't. Then you can recompose the gold. That's useful because that could get you gold, right? We like that. And then finally, the technology would be the tool. Oops. That's not a very good T there either. Or practice for something that isn't a tool. Like, agriculture is not a tool, it's a practice. To benefit society with this knowledge. And this is science. So we can take very basic fundamental things and turn them into your cell phone. Your cell phone is the product of ridiculous amounts of research. How does the screen work? Well, the screen works because people learned that applying a current to certain elements produces light. And when you put those elements in a very thin array connected to a circuit board, you can control what color lights come out. And then the result is the screen on your phone. How does the battery function? Well, lithium is really, really good at at passing away its electrons. It's a really good reducing agent. It gives a lot of energy if you get rid of its electrons. So we put lithium in a battery, and then we can make the batteries really small because they hold so much energy, and thus power your phone. So those are just two examples. The phone is made of plastic itself, which we learned was a resource that we could use when we dug up oil and then put a catalyst in it and it made plastic. And we were like, what is this material? Oh, we can use this because it's insoluble in water. It's also durable. Like, so technology and science is all around us. Oops. Too much on the screen. There we go. All right. So now that we know how to do this, we're going to research something and figure out some random facts. We're going to try and put them all together to do something useful with them. And then we're going to develop the thing that helps everybody out of those ideas. And then you launch the space shuttle and win the game if you're playing Civ 6. How do you do that, though? How do you do all of these things? Like, where do you even begin to do basic research? The applied research and the technology that come after will sort of fall into place if we know how to get started. So let's talk about how you get started. And the answer to getting started is actually not very scientific at all. It's just take a guess. Guess what's happening. Now, your guess is going to be based off of what you think is happening and other things that you've seen. For example, you might look at maybe like a fireplace. You put wood in, and you might think, well, if I put wood in the fire and I light it on fire, it releases heat. What if I put paper in there? What if I put plastic in there? What if I put aluminum in there? What if I put other things in the fire? Will they release heat? And you might be able to look at them and go, well, this is kind of like wood, so probably. This is not like wood, so probably not. You're making a guess. You're making a prediction about a question that you don't know the answer to. And so that's called a hypothesis. We're going to make a hypothesis about what we're going to try and do. Then we're going to do the thing. That's called an experiment. We're going to try and guess what's going to happen as the outcome. And then we're going to refine the outcome and the results that we observe and compare them to what we predicted and then refine our hypothesis. And so this is called the scientific method. There's a flow chart that explains this on the next page. But the general gist is, I think of an idea, I test the idea. Did the results of the test match what my idea was? If so, do it again. Do it with something else and keep doing it to verify it. If I got an answer that differed from what I thought, I have now learned the truth, and I can adjust my way of thinking and ask further questions. So here's that flowchart, and it's more or less just this process over and over and over again. So this starting situation is not really the scientific method. This is just sort of like a brainstorming, we'll say. This down here, oops, that's not the button I meant to hit. This right here is where you start. You're going to think of the problem that you are trying to address. That prediction is more or less the same thing. You're going to then test the problem. And then either it will support it or it will not. If your outcome does support your hypothesis is strengthened and you get to keep it. You can then further test it to try and strengthen it across more variety. For example, you might say, okay, if this plastic is not soluble in water, are all plastics insoluble in water? Because there's multiple different types of plastic out there, right? There's polyethylene, there's polyurethane, there's PVC, there is... I can't think of any other ones. Polystyrene, stuff like that. These are all different plastics. Are they all insoluble in water? You'd have to test them all. And once you did, you could then maybe make the blanket statement that all plastic is insoluble in water. It doesn't dissolve. But you would not be able to do that until you tested all of them. All right. So that's our starting point. We need to make a hypothesis. The hypothesis is going to be our guess from our brainstorm. Once we have the hypothesis down, we're going to do the experiment. The experiment needs to be controlled in such a way that we get a result that can only possibly be from the thing we're testing. For example, if I was going to test if Alka-Seltzer dissolves in soda, I could not do the experiment with a mixed beverage. For example, if I put soda, water, and alcohol and sugar into the container and dropped Alka-Seltzer in there, I could not discern whether it was the soda that was dissolving it or one of the other things. That would not be controlled. A controlled experiment only allows for one variable, the thing that we're testing for. The other thing that an experiment needs to do is it needs to be reproducible. I didn't write this on here, but we're also going to include this fact. If you do something and it's novel or neat or interesting, you're going to want to do it again. If you can't do it again, then it was a fluke and it's not going to be something that we can really make technology on, right? AGDQ is going on right now. I don't know if anybody actually watches the Awesome Games Done Quick, the speedrunning gaming marathon. If you had a trick in AGDQ that only worked 1 in 10 million times, that's not reliable. You would never do that. But if you can get it to work every time, it's reproducible, and that would be a thing that people would use. If you were cooking and 1 time out of a million, your food transformed into something really good, that's not reliable. We need a reliable method that will get us to the goal. The hypothesis and the prediction are more or less, in this chart, they should be more or less the same thing. So they're separating it here because this is just an idea, and then the prediction is, I think this will happen. I'm going to collectively say that those are the same thing for our purposes. I just could not find a better chart. Once you've done the experiment, you're going to get stuff out of the experiment. And that stuff's going to take the form of observations and data. And so observations and data are pieces of information that you get that help you understand what's going on. For example, in the Alka-Seltzer and soda experiment, how would you know if something dissolved? Well, you would see a gas bubble out, or you would see the solid disappear. If you visually observed that, that would tell you, oh, it did what I thought it should. That would be an observation. The word data is more specifically used for numerical quantities, but observations and data are more or less the same thing. One is qualitative and one is quantitative. So speaking of those terms, what do qualitative and quantitative mean? Qualitative would be related to qualities, which is why it's qualitative. What qualities does something possess? What would qualities of me be, for example? You could say that I have a beard, or you could say I like the color blue, or my skin is very pale because I'm a vampire. I don't know. Like, you could tell those things by looking at my picture down here. Yes, this is me right here. Those are qualities that you could attribute to something. So if something is qualitative in nature, you have ascribed a quality to it. So here are some example qualities that you could do. Now, these are all going to be very general and vague. There's not going to be anything specific about these qualities. They're just sort of points that we have ascribed to whatever it is that we are examining. A quantitative measurement would be something that contains a quantity or an amount. And so quantitative measurements always involve numbers because they have quantities. In order to get a quantity, we need to use a tool. And a tool will give us that information to some degree of accuracy. Oops, I didn't mean to go forward there. So, for example, if I measure the temperature in the room and I got this number, 72.4, that would be a quantitative observation. But if I said it is hot out today, that is a qualitative observation. Okay. The takeaway is, does it have numbers? I hit the wrong pen there. So a quantitative observation has numbers, and a qualitative observation does not. So you can instantly look at an observation and just note that. Now, there is a gray area. You could say, well, how many people are at this party? And you could just estimate that there's about 100. And that would be a pretty qualitative observation. If you measured with a tool, maybe you would get 192 because you counted the number of people that pulled a ticket from the the wheel at the front or whatever, and that told you. Or you had a clicker as each person walked in, and you just hit the button. So there is a gray area. So an estimate of a number would be qualitative. And if you have a number and it seems like a vague number and you aren't sure, look to see if an instrument or a tool was involved. If a tool was involved, you're going to get some degree of precision, and then it would be quantitative for sure. But a qualitative observation could be a very vague number. It's just not a specific number. All right. Now, let's suppose, I'm going to go back a slide here, that you get some information out of the scientific method. So I'm going to get a new color here. That's right, yeah. So the hypothesis is just the idea, and the prediction is what you think will happen under the condition you're testing. But for our purposes, you can put them together, because you sort of need both of them. I'm not going to test you specifically on a prediction, but a hypothesis would include the prediction for our purposes. Down here, I'm going to get information out of my experiment. That information on its own is going to be our basic science that we're going to learn. But if I can take that information and try and categorize it into how well it explains what's going on, that could be useful. So that's where this comes in. We're going to talk about scientific facts, laws, and theories here. And we're going to do that by watching a bunch of videos on YouTube. So the first thing we're going to look at is we're going to look at a scientific fact. A scientific fact is just any outcome that we can reproduce. But that's all that we get out of it. For example, you could make a scientific fact about what's going to happen to sodium metal here. We're going to do this experiment 3 times in 3 different ways, and we're going to compare the results. And so let me click on this. I got to pause the video here, because now I got to capture the video. Is this window 5? Yeah. So let's just crop to just the video, because now I can make it bigger. All right, so this is sodium metal in water version 1. So here we go. And this goes on for a minute, so we're going to stop there. But what happened when the sodium was put in the water? What did you observe? What scientific fact would you make based on this one experiment? I'll give you a hint. It's on the screen right now. What is combustion? Combustion is the reaction of something with oxygen. So this wouldn't be combustion because this is water instead. It blew up. That is definitely what happened. Can we use a more scientific... There we go, a reaction. That's what I'm looking for. A reaction occurred between sodium and water. That was definitely a reaction. Now, maybe that was a fluke. Maybe there was something else in the water. We should try it again. So let me click on the second link here. Uh-oh. It's not inappropriate. These people are just very professional.
Did you miss?
No, they're in. Didn't you hear the boom?
Did doofus?
Yeah, no explodies.
The longer it takes, the farther back to get. It takes a
Jeez!
Can you turn both ends?
Yeah.
And so they just keep doing this. Let's put more sodium in water. This is actually sodium metal. And they throw it in there.
Boom.
Somebody want to check to see that it's actually in there?
Damn it, I'm gonna die someday doing crazy shit like this.
Ow.
So, yes, very professional, as you can tell. They're doing this out in the woods with a butter knife on a log. But what scientific fact do you observe, despite their lack of equipment or even safety? Did we observe something totally different from the first one, or is it similar enough that we can get information about it? While you ponder that question, let's bring up experiment 3. So this is sodium metal right here in the tweezers. This is water with like a piece of filter paper, I guess, underneath. Here's the reaction. Let's show the water in, or the sodium in the water. What happens? That's really fast, so we're going to show it to you one more time here. Alright, so what conclusion do we draw about sodium and water? We've already drawn the conclusion, right? Yeah, it blows up. It reacts. It does stuff with water. Something happens. Yeah, there you go. That's a scientific fact. So you have now done basic scientific research. Is this useful for an application? Can we applied science this? Well, maybe we want something that explodes. So if I had some sort of mechanism that separates sodium from water, and then when an event occurs, the sodium would fall into the water and blow up. That would be an applied science of this. So I don't know why you would want that. I mean, what I'm basically describing is a bomb. But that's sort of where we're going with this. Now what I'm going to do is I'm going to have you make a hypothesis. So if you haven't already done so, go to periodictable.com, so ptable.com. And I'm going to hide this really quick because we're going to pop it back up in just a second. So we observed what happened with sodium. And what we're going to do now is I'm going to pick these elements down here. Don't worry about scientific law. We're going to talk about it in a second. I'm going to pick these elements right here. Potassium, rubidium, cesium. What I want you to do is I want you to go to the P table and find those elements. Potassium is K, rubidium is Rb, and cesium is Cs. Where are all those elements relative to sodium? And can you guess why I am picking them? Yeah, they're all in the same column. They're all alkali metals, right? So maybe if they are in the same column on the periodic table, they do something similar. So let's click on potassium here. And I gotta pause this quick because blink and you'll miss it. So we're gonna look at potassium. You've seen what sodium looks like. What do you expect potassium would look like? Think of an idea in your head, what you expect to happen, and then I'm gonna hit play, and we're gonna see if this matches your expectation. Alright, what do you think? We'll hit play. Oops, I don't want to go to the next video. We'll do it again. There you go. Was that everything you expected it to do, or was it different in some capacity? Yeah, it feels stronger, doesn't it? Stronger in what way? Stronger is a good word to use for it. Can you be more specific? Yeah, it reacted longer. How about, like, speed? Did it feel like it went faster or slower? These are all good. Yeah, it looked brighter. The color was brighter. Was the color the same or was it different? How many observations can we make about this? All sorts of them. In fact, if I do this, let's put, so there's potassium. There's its color. And I could go back to sodium here. We could put sodium's color. Are they the same? Let's assume there's no camera tricks. And that they're the same camera in the same circumstances. They're obviously different colors, so they are different. But they did similar things. So maybe there's a pattern here. Maybe putting these elements into water makes a pattern. So potassium was more reactive than sodium. What do you think will happen with rubidium here? Make a prediction and then see if it matches the result. Here's rubidium. That's it, it's done. I hope everyone enjoyed that. On these, we start doing them in slow-mo because they look really cool. Also, I like the 8-bit sound when you, like, super, super lo-fi it there. There it is one more time. Alright. Now we're starting to find a pattern here, aren't we? Once you get 3 things or so, you can start to see the pattern. So, what do you think's going to happen for cesium when I click this button for cesium here? Think about what might happen. Have an expectation in mind. And then, was this what you thought of? And I guarantee that at the very start, when I said, predict what potassium will do, you probably had very little idea, or maybe some idea. But by the time we got to cesium, you were like, I know exactly what's going to happen. It was probably really close, right? So what has your brain done? What has your brain done with all of this stuff that we have done in these experiments? What you have observed is called a scientific law. A scientific law is a pattern that you realize from a phenomenon. And that phenomenon was, well, if I take elements on the left side of the periodic table and put them in water, I get the same result. Furthermore, the result is that they get more explosive the further down the periodic table you go. Now, all a scientific law is telling you is how the matter behaves. So, our law summarized that the elements that we put in water explode and that they got more explosive the further down the periodic table. Why does it get more explosive the further down we go on the periodic table? That's not something that we can answer at this point in the class yet. What we can say is that our statements explain how the matter behaves, but not why. So this is a very important distinction between these two words. How and why, okay? Now, they are higher weight, but is it the weight that's causing that? Let's try and do that as an example. So, what's more heavy than cesium? If cesium was really explosive, then let's just pick an element that's next to it that's even more explosive. And so what I'm going to choose is now you could choose francium, but that wouldn't really answer our question, right? To eliminate weight from the example. So what I'm going to do, we saw cesium in water and it went boom, right? I'm going to pick this one. I'm going to pick barium. Barium is heavier than cesium. I'm going to put it in water, and you can see that when I put it in the water here, there's the barium. It's an oil right now. There it is. There's the barium, but it's not exploding. It's certainly not exploding. It's bubbling, so it's definitely reacting. But I would definitely not say that this is as strong as cesium, nor would I say it's as strong as, say, even sodium. It's just sort of bubbling. So by doing this experiment, we've pretty much eliminated that weight is the reason for this, because we found an example where something that was heavier did not react more violently. Could it be electronegativity? It could. And you can see that you could do all these experiments here. So I'm going to tell you the answer to what causes this. It has to do with ionization energy, which is not one we would have ever gotten to. We're going to talk about ionization energy in quantum mechanics when we do that in 161. Which we won't get to this quarter. That'll be next quarter. Now, if we do experiments and discover why this happens, we call that a scientific theory, okay? So facts are just observations that we see and we can reproduce. Laws are general observations for a wide swath of matter. Scientific luck, or not scientific luck. A scientific law needs luck to discover. There's tons of scientific laws out there. There's no luck involved in science. Like, you get the same outcome. Discovering it, though, requires luck. That's just me being a little cheeky. So I apologize that I've used a word as non-scientific as luck in the discussion here. But it takes effort to discover a scientific law. Scientific facts you can discover all damn day. You can do any experiment that you want to, and you'll get that. But a law requires us to put patterns together, and finding those patterns is where the luck comes in. The last element of the scientific method, scientific, all these words here, is the scientific theory. And the scientific theory is the highest level of understanding. And so the way that you get a theory is you do a lot of experiments to understand the very nature of matter. So in the previous question where we were talking about how do these elements react in water and why do they get more explosive, the why would be based on their ionization energy, which would be based on their electron configuration and the distance of those electrons from the nucleus. Now, those are all words that I have just said that we're not going to cover any of that in Chem 140. We're going to cover it all in 161. But you can see that the level of detail that we've gotten to describe why this is happening is very high. So a theory is the highest level of understanding that we have. Now, I'm going to poke fun at somebody. If you see somebody say this, you may have heard this slogan said by people, it's just a theory, right? In science, a theory is the best thing that you can get. And somebody who says it's just a theory does not understand science. They are being dumb. So you have my permission to slap them. Particularly the guy who does that, it's just a theory, a game theory. Like, ugh. As a scientist, I cringe every time I hear that. So a theory gives us all of the information to tell us why matter behaves at the level of detail that we see. I do that every quarter, and I don't think he has found me yet. But as a scientist, saying it's just a theory means it's nonsense. Like, it would be like saying jumbo shrimp. It's what is that? What is the name? Oxymoron. That's what I'm looking for. It's an oxymoron. A theory is very, very, very specific. And to have enough information to call something a theory means that we have done a lot of research. And so to just say, oh, it's just a theory is a complete misuse of the word. And so I find that obnoxious. This is just explaining how sodium is less reactive than cesium. So I believe that is it for this section. We're going to talk a little bit more about scientific theories on Thursday's lecture. We'll finish off chapter 1 then, and we'll get started with significant figures. But for now, I think that we are going to leave it at that because the class is over. So I need to do one last thing. I need to hit this button, and then I need to hit this button. And then I basically wish everybody a good evening because that's all we're going to do today. I will see everybody on Thursday. Remember, there is no lecture on Wednesday. Have a wonderful evening. Make sure that you're reading chapter 1. And I'll see you when we get back. Cheers.